Good morning. Now we will continue with our classes on Laplace transforms. Now this is the eighth theorem. So the theorem says like this, that is, if a Laplace transform of a function f of x is fs, then Laplace transform of integral 0 to x ft dt is given by fs by s. Okay, so this is another form of theorem, that is Laplace transform of integral 0 to x ft dt. If the given question is of the form, then your answer will be the Laplace transform of the function, that is fs, divided by s. So just write the Laplace transform of the given function and then you just divide it with the s. See, similar question. Obtain Laplace transform of 0 to x sin 2t dt. So this is of this form. So first what you do, you find the Laplace transform of sin 2t. What is the Laplace transform of sin 80? You have already studied. It is a by s square plus a square, right? So here your answer will be, in place of a you are having 2, right? So 2 by s square plus 2 square. Okay, that is your answer. Now you just divide that answer, 2 by s square plus 2 square. Here they have written it as 4, and just divide it with the s. So this will be your answer. See. Okay. Now one more example, Laplace transform of 0 to x sin t by t dt. That Laplace transform of sin t by t or sin x by x, that you have already studied in the last class. That was tan inverse, that is Laplace transform of sin ax by ax is equal to tan inverse a by s. That is a formula that you have studied in the last class. So here in place of a you are having 1. So first find the Laplace transform of sin t by t, that will be tan inverse 1 by s. Okay, now as per this formula you just divide the answer with the s. So your answer will be 1 by s tan inverse 1 by s. See. Okay, now two problems. Theorem 9, if f of x plus t is equal to fx, then Laplace transform of f of x will be 1 by 1 minus e raised to minus st integral 0 to t e raised to minus sx fx dx. So that is a formula which you have to apply. Here is the question. So if you are having a question of this form, you have to apply this formula. Okay. Here the given function is a periodic function. What is the period? 2 pi. Okay, so you just write the formula as such. See, this formula is written here. Now what you do, in place of t here, now we are going to solve this part. Okay, here in place of t you have written 2 pi. Why? Because time period is 2 pi. Rest everything is kept as such. Now the rest everything is integration. You are splitting this into 2, 0 to pi and 0 to 2 pi, and write the appropriate function in that limit. For from 0 to pi, what is the value? Sin t, and from pi to 2 pi, function is 0. So apply those values here. Okay, then this one will become 0, so it's not there. You are having only this. Okay, now this is of the form integral e raised to at sin bt. Integral e raised to at sin bt, the formula for which we have already studied in the last class. So this integral is of this form, integral e raised to at sin bt, and this integral has a formula. You just refer back the formula we have already discussed. Apply that formula here, then you will get this step. Then there is nothing, you just apply the limits. Then there is not much confusions. The rest everything is simplification and all. This will be your answer. Okay, so work out the steps by yourself. If you have any doubt in between, refer my steps. Okay, now another similar question. Again you just write the formula. then the function is having the value 1 in the limit 0 to 1, and it's having the value minus 1 in the limit from 1 to 2. Here also the function is periodic with period of 2. Then rest everything is integration. Okay, so this also you just work out. Here they have made some, here from the just note this step. Here they have grouped this term like this. Why? Because this we can write it as e raised to s plus e raised to minus s by 2 is cos hs. Okay, so this will be 2 cos hs. That is how it is written. Then rest everything is simplification. Okay, now finally we will reach at this answer. So this is also integration and further simplification. There is no complicating steps. So as I said before, work out these two problems by yourself. If you have any doubt, you refer my steps. Otherwise you just work out in your own way and check the final answer. Okay, now we will learn the next session, that is inverse Laplace transform. Till now we have studied Laplace transform. Now what will be inverse Laplace transform? Just the inverse or the reverse. Okay, if f of s is a Laplace transform of the function fx, then fx is said to be the inverse Laplace transform of s and is denoted by L inverse fs equal to fx. Okay, that is Laplace transform of f of x. We know it is fs. Now what will be L inverse of fs? It will be f of x. That's all. Now one problem. Laplace transform of e raised to at is 1 by s minus a. Okay, that we already studied. The first formula that we have discussed in our first class on Laplace transform. Laplace transform of e raised to ax is equal to 1 by s minus a. So Laplace transform of e raised to 2t, it will be 1 by s minus 2. Okay, now L inverse of this one will be e raised to 2t. Okay, now Laplace transform of sin x, you know it is 1 by s square plus 1. Now what will be L inverse of s square plus 1? It will be sin x. That's it. Okay, just the inverse of Laplace transform, that is inverse Laplace transform. Now theorems. L inverse of k1 fs plus k2 gs equal to k1 L inverse fs plus k2 L inverse gs. A similar theorem we have studied in the Laplace transform, right? The first theorem. So this was a theorem that you have studied in Laplace transform. Laplace transform, you have two functions, sum of the two functions, and each function multiplied with a constant, say k1 and k2. This one, that is k1 fs plus k2 gs. Now L inverse of this one will be this. Okay, now let us do some problems. Your question is L inverse of 3s plus 5 by a square. First what you do, you just split this question into two. 3s by a square, 5 by a square. Now 3 is a constant, take it outside. Now what you have inside? L inverse of 1 by s. You know Laplace transform of a constant, say a, is a by s. Here your constant is 1. Okay, so it is 1 by s. So L inverse of 1 by s will be 1, right? So here your answer is 3 into 1 plus 5. Just take it outside. Laplace L inverse of s square is x. Why? Because we have already studied Laplace transform of a variable, say x, is 1 by s square. So L inverse of s square will be, L inverse of 1 by s square will be x. That is how it is written. Okay, so first study well, get thorough with the Laplace transform. Then only you study inverse Laplace transform. Why? Because then only you will understand. Okay. Now next question. L inverse of 1 by s raised to n. We have already studied L Laplace transform of x raised to n minus 1 is n minus 1 factorial by s raised to n. From here 1 by s raised to n will be 1 by n minus 1 factorial into Laplace transform of x raised to n minus 1. Okay, so what will be L inverse? Taking L inverse on LHS and RHS, what will be that? 1 by n minus 1 factorial is a constant. Now L inverse of L x raised to n minus 1 is x raised to n minus 1 itself. Okay, so your answer is x raised to n minus 1 by n minus 1 factorial. N minus 1 factorial can be written as gamma n. Okay. Now another question. L inverse of s plus 2 the whole square by s cube. Just expand s plus 2 the whole square. You will get like this. Now split it into parts. Now L inverse of 1 by s we have already said it is 1 plus 4. L inverse of 1 by s square it is x plus 4. 1 by x cube it will be x square by 2 factorial. Okay. Why? Because Laplace transform of x raised to n we have studied it as n factorial by s raised to n plus 1. That is what it is applied here. Okay. So get thorough with the formulas for Laplace transform. Another question. L inverse of 45 root s by s raised to 4. 45 is a constant, take it outside. Then what is remaining in the bracket is L inverse of 1 by s raised to 7 by 2. Okay. Now this is of the form L inverse of 1 by s raised to n. That the formula will be x raised to n minus 1 by gamma n. Here what is your n? 7 by 2. So you will have x raised to 7 by 2 minus 1 by gamma 7 by 2. Okay, simplify it. Gamma 7 by 2 is 5 by 2 into 3 by 2 into 1 by 2 into gamma. Okay, now cancel all the part and simplify it, and what remaining will be this one, this answer 24. Just simplify these terms. Okay, then gamma 1 by 2 is root pi. Okay, so just work out and see whether you are getting this answer. Now L inverse of 2s by 4s square plus 16. So here you just rewrite this 4s square plus 16 as this one. Okay, now 2 and 4 this get cancelled. 1 by 2 it is taken outside. Rest remaining is kept in bracket. 1 by 2 L inverse of. Now see s by s square plus 4. That is of the form, because Laplace transform of cos x, what was it? It was s by s square plus a square, right? Here also you are having s by s square plus a square, that is 2 square or 4. Okay, so you get that this is of the function cos, so it is cos 2s. Okay, cos ax, Laplace transform of cos ax is s by s square plus a square. Now so from here you know it is of the form cos ax. Here your a is 2, so your answer will be cos 2x. Now another one. If Laplace transform of f of x is fs, then L inverse of s of s minus a will be e raised to ax f of x. Okay, this we have studied a theorem, right? Laplace transform of e raised to ax f of x equal to f of s minus a, right? So what will be L inverse of f of s minus a? It is e raised to x fx. That's it. Okay, this theorem we have already studied under Laplace transform. Just the inverse will give you this theorem. Okay, now question L inverse of n factorial by s minus a whole raised to n plus 1. Because n factorial Laplace transform of x raised to n is n factorial by s raised to n plus 1, right? This Laplace transform of x raised to n, we have already studied that it is n factorial by s raised to n plus 1. Here you are having a here. Okay, so what will be the answer? Here you will have an e raised to ax. Okay, then only you will write here an a here, s minus a whole raised to n plus 1. So your question is this one. What is the L inverse of this? L inverse of this one will be e raised to ax x raised to n. Okay. L inverse of 10 by s square minus 2s plus 3. Just write 10 in a form 5 into 2. Then write s square minus 2s minus 3s, s square minus 2s plus 1 minus 4 because it is the same as minus 3. Then that we write in order to bring it in a particular way. Okay. Now just split this denominator as s minus 1 the whole square minus 2 square. Okay. Because this is the same as this one. Okay. Now 5 is common taken outside. What is remaining inside is 2 by s minus 1 the whole square minus 2 square. We know Laplace transform of a by s square minus a square is sin h ax, right? But here you are having a minus term also, so you will be having e raised to x. This is of the form e raised to ax sin hx. Okay, so just study Laplace transform first, then only you will be able to quickly understand what is written here, because everything is simple. The only thing is that you must be thorough with the formula and techniques in Laplace transform. Okay, next theorem, L inverse of f raised to n s equal to minus 1 whole raised to n x raised to n L inverse of f of s. This proof is not that much important. If you want, you just go through. These problems are important. Okay, so we will study this problem. L inverse of minus 1 by s plus 1 the whole square. You can rewrite it as L inverse of d by ds of 1 by s plus 1. D by derivative of 1 by s plus 1 will be this one. Okay, so L inverse of first derivative of the function. Okay, that is f1s. Now L inverse of f1s is can be written as minus 1 whole raised to n x raised to n L inverse of f of s, because we have already studied a theorem in Laplace transform relating the derivatives. So refer that theorem first, then work out this problem, then you will understand these steps. Okay, I am not explaining it again, the rest everything is just simplification. Okay, because in the last class we have discussed about a theorem under Laplace transform that discusses about the derivatives. Okay, so refer that theorem. It is something like this. Okay, that is Laplace transform of the nth derivative of a function will be minus 1 whole raised to n x raised to n Laplace transform of the function. Like that, a formula you have studied under a theorem in Laplace transform dealing with derivatives. So this problem is based on that. Okay, so first go through that formula and then apply the reverse condition. Then you will get this answer as minus x e raised to minus x. Now similar problem is this one. They have asked for the second derivative. See, this one is actually the second derivative of 1 by s plus 1. Okay, again see, compare these two. Nothing is there. One is about the first derivative of 1 by s plus 1. Second question is about the second derivative of 1 by s plus 1. Minus 1 whole raised to n, it is written as such, x raised to n. Here you have written L inverse of f of s. That is L inverse of first derivative of f of x. Okay, here also L inverse of first derivative of f of s. Here the only thing is that since we are dealing with the second derivative, the value of n becomes 2. Here the value of n was 1. That is the only difference. Okay, so first refer the theorem that you have studied under Laplace transform. Which theorem? The theorem that dealt with the derivatives. That is, you will see something like this. Okay, that theorem. Okay, then you go through these two problems. These two problems are very important. Last one, L inverse of fs by s is integral 0 to x ft dt. Okay, this is a theorem and its proof. One problem based on this theorem is given here. Obtain L inverse of 1 by s s square plus 1. This is of this form, right? L inverse of fs by s. So your answer will be integral 0 to x ft dt. So you write it as integral 0 to x ft dt. Integral 0 to x, what is the function? Ft dt, L inverse of 1 by s square plus 1 dt. What is s square plus 1? You know, Laplace transform of sin at is 1 by s square plus 1. So 1 by L inverse of 1 by s square plus 1 will be sin t. Then just apply integration. You will get the answer as 1 minus cos x. Another question, L inverse of 1 by s square plus 1. This is also of this form, that is integral, that is Laplace transform of function f of s by s. Answer is integral 0 to x ft dt. So here also just write all the following steps. Okay, write in this form, that is L inverse of fs by s. Fs is 1 by s into s square plus 1 s. See, then what will be your answer? Integral 0 to x ft dt as per the theorem. Okay, so integral 0 to x ft dt. Here your ft is L inverse of f of x, and what is that? 1 by s into s square plus 1 dt. This we have already solved, so you are just substituting that answer here and then apply the integration and limit. You will get the answer as x minus sin x. So these four problems are very important. This one, then this question, then this one, and finally this question. Okay, these four questions. So before that, going into these questions, just work out the theorem that I have already said. That is the theorem in Laplace transform that deals with the derivatives. Then work out these problems. Okay, so this problem is very important. At the same time, this problem also. Okay, so work it out. Then this theorem, the problems based on this theorem, first one and this one. Okay, so these four problems are important. Okay, thank you.